Assalamu alaikum. Welcome to my video series on data science. In today's video, we will dive into data augmentation, the final topic in our data transformation section. We will discuss commonly used techniques for different types of data and finishing up coding demo on augmenting tabular data. One of the main reasons behind the data augmentation is class imbalance problem. Class imbalance is a common issue in machine learning where some categories have way more examples than others, causing the model to focus on majority class and overlook the minority class. For instance, in a medical dataset where most examples are labeled as no disease and very few examples are labeled as disease, the model may only learn to predict no disease, missing actual cases. Data augmentation is a strategy used to increase the diversity of a training dataset without actually collecting more data. By making slight adjustment or transformation to existing data, we create new samples that help improve models' ability to generalize. This is particularly useful when the available data is limited or imbalanced. It reduces overfitting by exposing the model to variations in data. It learns to handle unseen patterns better. It also improves the model's ability to generalize to unseen data. Let's discuss data augmentation techniques in image data. Common techniques include geometric transformations, color space augmentation, noise injection, and GAN-based augmentation. Geometric transformations include rotating, flipping, cropping, scaling, or translating the images. You can see some examples in the picture. Color space augmentation randomly adjusts the brightness, contrast, saturation, and hue of the image. Noise injection is a data augmentation technique where random noise is added to the pixels values of an image. This technique helps to increase the diversity of the training data and makes the model more robust to noise in real-world images. GAN-based augmentation uses a special type of neural networks called generative adversarial networks to create new realistic images that are similar to the original dataset. This helps increase the diversity of training data and improve the performance of machine learning models. Let's discuss textual data augmentation techniques. It includes replacing words with their synonyms, inserting random words into the sentences, removing the random words from the sentences, translating the text to another language and then translating it back to the original language, and rearranging the order of the sentences in a document. Tabular data augmentation techniques includes adding small random noise to numerical features, randomly shuffling rows or columns in the dataset, creating new features by combining the existing ones, and generating synthetic samples from minority class in imbalanced datasets. Let's have a demonstration of data augmentation using SMOTE in Python. Here we have imported the necessary libraries including the SMOTE library from the oversampling. We are using the census dataset for this example, which contains different features like ID, education, age, capital gain, race, capital loss, hours per week, and gender. And the class label contains two values, greater than equal to 50k or less than equal to 50k. Let's find out how many elements are in each class. So we can see that less than 50k have almost 22,000 while greater than 50k have 6,700, which shows a clear class imbalance issue. Now we need to prepare our data for the SMOTE, which includes removing missing values and feature encoding. So first we will encode the categorical columns like education, race, gender, and class to numeric. We can see that they have been converted to numeric. Let's print the data types of each feature, and we can see that the capital gain has object data type which needs to be converted to numeric. So we will use pd.toNumeric function to convert this into numeric. Now the data type has been converted. Let's check for the null values, and we can see that capital GAN has 4 null values. So we will use fill NA and replace the null values with the mean of the column. Now we can see that there are no null values. First we will create a SMOTE object, and then we will call SMOTE function fit resample. We will pass features and label to this function. It will return the augmented features and labels. Here we can see that it has returned us almost 45,000 records, while our original dataset contained 29,000 records. We can display the values of the features and the labels. So here is the augmented version of our dataset. So summarizing today's discussion, data augmentation is a powerful technique to enhance the performance of a machine learning model, especially when working with limited or biased datasets. In this session, we discussed different data augmentation techniques for image, text, and tabular data. We also demonstrated the implementation of SMOTE in Python. Remember to experiment with different techniques and evaluate their impact on your model's performance. Our next topic would be machine learning modeling. If you found this video helpful, don't forget to like, share, and subscribe for more videos on data science and AI. See you next time.